Welcome to Study Loop.
Let's go ahead and factor x to the fourth plus 1. So here we can use the following. Let's go ahead and add in a 2x squared there, and then we'll make up for it by subtracting it at the end. And then we can write this as x squared plus 1 squared, and then minus root 2 times x, and that's all squared too. And then here on this latest expression, we could do difference of squares. There's the first, and then here's the second. So now we can rewrite this, just the integrand, not the integral itself. So we can go ahead and check that these guys are irreducible. B squared minus 4ac for both of these quadratics is negative. So these do not factor over the real numbers. So using what the author calls case 3, our partial fraction decomposition should look like the following. And then cx plus d, x squared root 2x plus 1. We have an x there, plus 1. Got a little sloppy over here, sorry about that. Should be x. Okay, now let's go ahead and multiply both sides of this equation by the denominator on the left. So we get 1 on the left, ax plus b. And then here, I forgot to add a 1 there, sorry about that. And then we have x squared plus root 2x plus 1. And similarly for the cx plus d, x squared minus root 2x plus 1. Now let's go ahead and combine like terms here. Or first, let's just go ahead and expand this whole thing. After we expand and simplify the right-hand side, we should get a plus c. So I did skip a short step there. You would have to expand the right-hand side first. And now I'm just pulling out the x cubed, x squared, and so on. All right, that should not be there. Let me erase that. So then you pull out the x term, a root 2b, c minus root 2d. And then now at this point, you would match up the coefficients to see that a plus c is 0, the second term is 0, the third term is 0, and then b plus d is 1. This is a 4x4 system for us to solve here for a, b, c, and d. So we do have a plus c equals 0. We could go ahead and plug in this fact, and we have an a and we have a c here. So we end up with root 2b minus root 2d equals 0. This implies b equals d. And if we plug this fact into this equation here, we get b equals d equals a half. And now similarly, we could go ahead and solve for a and c because we have one equation up here, a plus c equals 0, and then plug in our values for b and d into this equation here. You get root 2a, root 2c equals minus 1. So solve this 2x2 system over here on the left. for A and C. So here you could go ahead and multiply both sides of this equation by root 2. And then go ahead and add those together and then solve for A. And then you get C equals 1 over 2 root 2. So now we have our values for A, B, C, and D. Let's just go ahead and plug these into the integral. For our now we're plugging into our partial fraction decomposition. So we have integral over here, our denominator, which we'll deal with in a second. We'll have to complete the square on that denominator. And then let me just break this integral into 2. And then also over here, same denominator. Oh, not the same. This one has a plus. And the x is not inside the radical, just the 2. Now we could go ahead and take this denominator, complete the square. So let's replace both the denominators with this. And then there, after this point, we could go ahead and do a u sub. So du equals dx. And we could also write x equals u plus 1 over root 2. So let's go ahead and rewrite the numerator term here. So working on this integral first. Negative 1 over 2 root 2. Then u plus 1 over, and then root 2. Using this equation here for x. Plus 1/2. So this is negative 1 over 2 root 2 u plus 1/4. So now let's go ahead and rewrite this first integral all in terms of u. So I'll go to the next page for that. Plus 1/4. And then on the bottom, we have u squared plus 1/2. So let's go ahead and simplify this. Pull out the constant. U squared plus 1/2. And then let me go ahead and pull out that 1/4. So just splitting this integral up into 2. Let me just write this as 1/2 again. And then du as well. Du here too. Now for this, feel free to do a u sub for this integral here. And then for the second integral, we should do a trig sub, unless you've memorized something from the table. So go ahead and use these substitutions to evaluate these integrals. And then I'll just write u squared, no absolute value here because u squared plus 1/2 is positive. And then after the trig sub, or if you memorize the table, we have this. And then we could go ahead and plug everything back in terms of x. And also here, I should have had an additional 1/2 from the u sub. Sorry about that. That's where the 4 is coming from, 2 times 2. So just replacing u in terms of x. And then here as well. So now that takes care of the first integral from the previous. We still have the second integral. So for the second integral, you would just go ahead and use the substitution, x plus 1 over radical 2 instead. And then for the other integral, the second one that we didn't evaluate, so both of these integrals are very similar. We went over the first one in full detail, and the second one is too similar to write out in full detail again here. So this would be the second integral, and then adding the results together, we have the previous integral from the last page. So this was our first integral that we worked out in full detail. And then now we add the answer from this page. Then we have root 2x plus 1. And then now finally we'll go ahead and add our constant of integration c. And that's our final answer.